So, um, good day, everyone. So, my name is Chicalis Andales, and today I am going to discuss about the introduction to emerging technology, which is the chapter one. So, now let's have the overview of this chapter. So, in this chapter, we will going to learn what are emerging technologies and historical context and technology evolutions and key technology categories covered in this chapter and impact on society, business, and daily life. And lastly is the challenges, ethics, and the road ahead. So now let's move on to the next page. So, what are emerging technologies? So, technologies reshaping how we live, work, and interact with the world. So, when we say technology, so it defines the conceptual, the boundaries of what makes a technology emerging rather than identifying tools that are fully realized. It highlights the technologies that are currently developing, experiencing exponential growth, and exhibiting a broad scope. And crucially, it points out the convergent natures, meaning this isolated technology frequently merge, creating entirely new hybrid fields of capability while actively disrupting legacy and industries. So first is the currently developing. So currently developing, it means it developments are early adoption phase, not yet mainstream across all sectors, and rapidly growing. So it characterized by the novelty, rapid growth, and significant disruptive potential. So later on, I'm going to discuss about this. And the next one is the project impact. So, well, it significantly alter industries, economies, and society at large, and the wide scope. So, for example, the span AI, IoT, blockchains, AR/VR, robotics, and 5G connectivity. But on later on, I'm going to discuss about that scopes. So now is the last is the convergence. So convergence, it is the technologies converge with each other to create entirely new possibilities. So it's considered that this shift from classic celluloid desktop with design to this uh, decentralized, yes, and interactive frameworks. A technology is actually emerging when it forces industries to rewrite their operational rules because it bridges multiple domains simultaneously. So now let's move on to the next page. All right. So now let's have the characteristic of emerging technologies. So there are five defining traits that set emerging technologies apart. So these slides it evaluates the five hallmarks that differentiate the emerging technologies from standard incremental innovation. So first is the radical novelty. Yes. So radical novelty is this distinct from everything that preceded them, a genuine leap, not an incremental update. So it means that it is introducing foundational concepts previously absent from the markets. Yes, and next one is the fast growth. So when we say fast growth, it growth is adaptation curves or stepping quickly. What's a rare today becomes standard within a year. So it scales at an exponential rate, outpacing traditional adoptions curves. Yes, and the coherence. Coherence is a recognizable, stable identity or the trajectory that experts can define and study. So it means it shows that the trajectory toward a unified identity and a standardized, yes, use cases. Then the fourth one is the prominent impacts. All right, so when we say prominent impact, it affects economy, society, or the governance in measurable, wide-reaching ways. And that means is the alters what we say alters socioeconomy's identity and standardize use standardized permanently, yes. And the lastly is the uncertainty. So when we say uncertainty, it is the outcomes are not fully predictable. Ambiguity is inherent in the early stages, so it means that carries a unpredictable risks and highly volatilized futures pathways. So, in this slide, the example is the quantum computing risk. Yes, it highly volatilized future pathways. Yes, it's a radically novel and scaling rapidly. And yet, it contains massive systematic uncertainty because its research just cannot fully predict exactly when it will break current encryption methods on how it will stabilize globally. Alright, so now let's move on to the next page. Alright, so now a brief a brief history about the technology evolutions. Alright, so these slides maps out the linear when we say linear evolutions of a human industrial capabilities across the major historic milestones. Yes, beginning with the first industrial revolution in the 1760s, driven by the mechanized steam power. So it traces the trajectory through the seconds. So that the second is the electricity and mass productions, and the third is the computers and the internet, leading up to the digital transformation, defining today's landscapes. All right, so in this I do all right. So the first one is the 1760s. So that what we call as industrial revolutions. So in the industrial revolution, there are the steam power, mechanizations, factory productions, and after 1760s, uh, there is 1880s. So this is 1880s is this is electrifications. So electrification is the power grids, telegraphs, mass communication, and 1940s is the computing era. So in the computing era, there are the mainframes, transistors, and early programming. So now in the 1990s, so these are the internet age. Uh, so it is the commonly we see in the internet is the www, or a world wide web, and the e-commerce, global connectivity, and lastly, I not lastly but second to the last is the 2020s. So it is the mobile era. All right, so the it's viral on 20s is the smartphones on apps, especially the games, yes, social media platforms, all right, like Facebook, Instagram, and yeah, Messenger, TikTok, WhatsApp, WeChat, like that. So now is the today, or what we call the fourth revolutions. So in this fourth revolution, there are the AI, IoT or the internet. All right, so later on I'm going to discuss about that. And blockchain, 5G, or digital transformations. All right, so this historical context is help us to understand the present just as the 1990s. So it introduced the World Wide Web, yeah, the WWW. So in radically altered communication, the modern era acts as a evolutionary step where computing is completely decentralized and deeply woven into our everyday environments. Alright, so now let's move on to the next page. Alright, so the fourth industrial revolution, or what we call the 4I, excuse me, 4IL. So, building on the timeline, these slides explore the specific concept of the fourth industrial revolution, which is the 4IR, a phrase popularized by the Klaus Schwab. Alright, so this one, Klaus Schwab, WEF on 2026. So the core thesis of a 4IR is velocity, scope, and the systematic impact. It represents a reality where the boundaries separating the physical world, digital networks, and the biological systems are dissolved into a singular, unified and ecosystems, right? So the first is the fusion of physical, digital, and biological worlds. So yes, it is a technology that operating at unprecedented scales and speeds. So it has the blurs lines between human and machine capabilities. Then the lastly is the impact every industry, healthcare, finance, manufacturing, education. So yes, this fourth industrial revolution is a machine. All right, so this is the pillar. I mean this is an advanced medical devices such as neutral interfaces or smart cybernetic prosthetics serves as the clear example. So these systems rely on the biological nervous systems to command a digital microchip, which is turned to manipulate a physical mechanical lamps. Alright, so now let's move on to the next slides. So it is core technologies pillars. Alright. Okay, so artificial intelligence, or what we call as AI. So what is this? So this is a simulations of human intelligence processed by machines. All right, so we already know that this is a familiar and common we use on every daily lives. So these slides introduce the artificial intelligence, or what we call as AI. So defining it as um, the simulation of human intelligent processes by the computer systems rather than the viewing AI as a monolithic tool. The material unpacks it into specialized subfields and machine learning, pattern recognition from data. So deep learning, or what we call neural networks, model loosely after human brains, and computer visions. So it enabling machine to visual process environmental imagery. So subfields. So these are the subfields: machine learning, deep learning, natural languages processing, and the computer visions. So the applications, These are the virtual assistants, yes, recommendation systems, yeah, like when we uh, search on the internet, so it will come out the recommendations. Yes. Next is the medical diagnosis. Yes, AI can do that, and the fraud detections. All right. The next is the landmark examples. All right. So the landmark examples is the Chat GPT. It is an open AI. All right. So it is a commonly website that we use in every daily life, right? Okay. And the alpha folds, or what we call a deep mind, self-driving vehicles, DAL-E image generations. Alright, so nowadays there's a lot of people using this AI. Like they are creating more, creating photo, or they editing using prompt. Yes. So ChatGPT can do that. Alright, so AI is transforming decision making across every sectors. Yes, from healthcare to finance to educations. Alright, so this pillar is active across society today. So power large language models like the ChatGPT, yes, for text generations, and AlphaFold for scientific and medical protein discovery, and advanced sensors, yes, with the autonomous vehicles navigating urban traffic patterns. Alright, so now let's move on to the next page. Alright, so okay, so IoT, or what we call the Internet of Things. So what is this? Or what is the meaning of this IoT? So it is a network of physical devices embedded with the sensors and internet connectivity. So it has a 15 billion plus, all right, so connected on this divide globally as of 2025 and 2026. All right, so this slide examines the Internet of Things, or what we call as IoT, or characterize it is a massive, decentralized global network of physical hardware. By embedding sensors, software, and advanced connectivity modules directly into everyday items, static tools are converted into dynamic data nodes capable for collecting and transmitting telepathy and real lives. So just like smart homes. All right. So when we say smart homes, it is a connected appliances, lighting, and security system. Yes. When we say smart homes, uh, it is a security system which is where it is a automatic door, automatic window, automatic closing, open. It's like that in your homes. All right. So next is the wearables. Yes. So when we say wearables, it these are the uh, these are the things that is a wearable. So which is the health monitors. Yes, we can see that on the PC, or yes, and smartwatches, fitness tracker. All right, so when we say fitness tracker, it is a wearables. All right, so it can help to track when you do a fitness workouts. All right, smartwatch. So smartwatch is an watch. Yes, it is watch, but the different is it is a touchable, just like a screen on your phones. All right. The next one is the industrial monitoring. So it is equipment sensors, predictable maintenance, and supply chains. And lastly is the smart agriculture. So when we say smart agriculture, it talk about the natures, land, and everything that we can see in this earth. So for the example, soil sensors, automated irrigations, and crop monitoring. Alright, so key challenge. It is a security, data privacy, and interoperability remain active areas of concerns. Alright, so the most problematic example is the modern smart home. Alright, so within this system, your thermostat, motion activated security camera, yes, that is the examples, and domestic appliances continuously share data, enabling automated adjustment and giving you remote control via smartphone from anywhere in the world. So it means that when you go uh, when you go other country, or you go to city or other houses, we one click only on your phone, you are I mean you controlled your house. All right, so okay, now let's move on to the next page. All right, so blockchain technology. So blockchain technology, it is a distributed immutable ledger that records transactions across decentralized networks. So when we say blockchain, this is provides the structural overview of blockchains. So explaining, it is a distributed, decentralized ledger designed to record transactions across the peer-to-peer networks because it relies on a cryptographic verification, I think, and chronological linking, and the data become immutable, meaning it cannot be altered or wiped or forged by any single malicious entity without compromising the entire chains. So first is the transparency. All participants can view the shared transactions history. So it's only transactions that can be viewed by the participants. Alright, then next is the security. So security, it is a cryptographic hasting makes records tamper proof. All right, just like uh, just like when we log in on our Facebook account. All right, so they provide authentication. So it is a security purposes that you are using your account. All right. And the next is the decentralizations. So no central authority validated by the network consensus. All right. And these are the applications. So finance, when you say finance, so this is the cryptocurrency, cross-border payments. All right. So in sub supply chains, so these are the product provenance, logistics, logistics tracking, and for contracts. So it's smart contract, legal automation, and lastly is the identity. So it is the digital identity or the credentials. All right. So beyond these cryptocurrencies like bitcoins, this is the technology underpins by the smart contract. All right, so it belongs to a smart contract. Yes, these are the self-executing digital protocols that that automatically transfer funds or ownerships of digital assets the exact moment specific conditions are verified or cutting out intermediary middlemen like banks or brokers. All right, so those are the examples. So Bitcoin. So in 2009, introduced the blockchain as a publicly assistive technology, the foundation for the decentralized internet of value. Yes. All right, so now let's move on to the next page. All right, so it is the cloud computing. So cloud computing, it is a delivery of on-demand computing services over the internet, scalable, flexible, and global. All right, so this slide details cloud computing, which is a ship computing the resources away from the localized hardware to on-demand digital services delivered entirely over the internet. So the presentation breaks down the architecture into three classic tiers. Alright, so these are the IaaS, PaaS, and SE, excuse me, SEAS. Alright, so now, okay, first is the IEES. So it means the infrastructures as a service. So it is a virtual servers, storage, and networking on demand. Alright, so for example, AWS, EC2, and Azure VMS. So what does that mean? So it renting virtualized raw hardware and servers. Alright, so next is the platform as a service. So it is a PEAS. So it is a development tools and middleware for building apps. Alright, for example, Google App Engine and Heroku. I don't know, I don't have any idea about this Heroku, but Google App Engines. Alright, so it means it is accessing specialized environment tailored for the software development. And lastly is the SaaS, or what we call the SEES. So it is a software as a service. So it is a ready to use application delivered over the web. Alright, for example, Gmail, yes, we already use these apps. Salesforce and Microsoft 365. So Microsoft 365, or what we call this an Office. So these are the PowerPoint, Word, Excel, and uh, what is Steam, Steam. All right, etc. All right, so major providers. So AWS is a Microsoft Azure's or Google Cloud platform. All right, so SES is a runningly fully polished and user application via web browsers. So we can see this. It's either apps or websites. Alright, so it is a daily collaborative tool such as using Google Drive or Microsoft 365 to instantly edit documents with coworkers in real time and represent classic softwares as a services is ES operational framework. Alright, so now let's move on to the next page. Alright, so big data and analytics. Alright, it is the data sets too large for traditional tools defined by the 5 V's. Alright, so big data through the framework of the 5 V's, which is the volume or share scales of data, and velocity. It is the speed at which data is created and processed. And variety it is a structural diversity like text, audio, video, etc. Yes. Veracity. So this is the trustworthiness of the data. And lastly is the value. It is the actionable insight derives. So the slide explain how advanced analytics convert raw and unorganized noise into a clear strategic choices. All right, so now let's have the first V, which is the volume. So it is the petabytes of data generated every seconds, and velocity. All right, is the speed of data creation and processing. All right, and the variety, just like text, image, videos, ensures data. Variety, accuracy, and trustworthiness of data, yes. And the value is the insight derived to derive real decisions. Alright. And the tools is the Hadoop's Apache Spark, am I right? Or the Power B or Power BI, I think, and Tableau. All right. And applications is the customer behavior, fraud detections, yes, precision medicines. All right. And lastly is the data-driven decision are replacing intuition in most industries. All right. So enterprise skills, e-commerce platforms like Amazon, leverage these models by analyzing millions of disparate customer clicks, searches, and cart additional every single seconds, or transforming that massive data flow into focused product recommendations. Alright, so now let's move on to the next page. Alright, it is the augmented and virtual reality. So it means it is immersive technologies that blend or replace physical reality with digital experiences. Alright, so it breaks down the difference between immersive technologies designed to alter human perceptions. Alright, so there are three. Alright, so first is the augmented reality or ER, and virtual reality VR. Yes, this is the ER, VR, and MR. So what is MR, Mister? No, it is a mixed reality. Alright, so first is the augmented reality. So it is the overlays digital contents on the real world without replacing it. Alright, just like Google Maps leave direction, IKEA furniture preview in your room, and medical imaging overlays. Alright, so now, so I mean, now it is means that this project digital graphics overlays onto the existing physical worlds. Alright, so that is what we call as R is AR. Alright, so now is the virtual reality. Alright, so it is a commonly tools that use on every people. It's either in the game hub or in the mall, I think. Yes. So it is a fully immerses the user in simulated digital environments. So it is a training simultaneous, just like medical, military. All right, and immersive gaming experiences. Yes, we can do a game using VR. All right, virtual architectural walkthrough. All right, even your work, if you are an architect, civil engineer, or whatsoever, you can use a VR to make a 3D work. All right, and lastly is the mixed reality, or what we call MR, not Mister. So it is a merged ER and VR for interactive context aware experiences. So it is a remote collaboration, MS Hollands, yes, industrial design prototyping, metaverse social platforms. All right. So it is allows physical objects and digital assets to coexist and interact dynamically in real time. So the metaverse concept relies heavily on the convergence of AR, VR, and MR technologies. So it is an immersive application. For example, include the consumer tools like Pokemon Go or specialized excuse me, retail utilities such as IKEA Creative, so which lets user visually overlay exact 3D models of new furnitures onto their physical living room floors or using a phone cameras. Alright, so now let's move on to the next page. Alright, so robotics and automations. Alright, so it is a machines, yes, designed to perform tasks with minimal or no human interventions. Alright, okay, so these slides, alright, so these slides, it highlights the intersection of physical, yes, physical machines that software automations. It looks at the transition from classic industrial manufacturers, so robots, to AGA services, robots and software, yes, driven robotic processes, automation, or what we call as RPA, yes. So the focus is on how these systems minimize manual interventions, optimize precisions, and reshape labor markets. Alright, so first is the industrial robots. So when we say industrial robot, this is a welding, assembly, and packaging and manufacturers facility precision consistently 24/7 operation. So these are the robots that can be used on the factory, uh, like yes, just like welding, assembly, and many more. All right. Next is the service robots. So service robots it is surgical systems or Da Vinci. So some of robots are I do can do drawing, digital painting or whatsoever, and delivery drones. Yes, delivery drones are commonly used on the others country like Korea and Japan. Yes, Japan. So Japan is advanced. They are have an advanced technology, which is the drone. Yes, the delivery drones that we don't have on in our country. Yes, and warehouse logistics like Amazon Robotics. All right, so these are the using these are the robots that do in the warehouse, like on the company Amazon's. Yes. All right, so now is next is the RPA. So what is RPA? It is a robotic process automations. So it is a handles repetitive digital tasks like data entry, invoice processings, and report generations. So I have a key consideration. So automation raises fundamental excuse me, fundamental questions about the futures of work. Which job will be displaced? So which will be augmented and which will be created? All right. So nowadays we are surrounding by the robots. So in healthcare, the Vinci surgical systems allow human surgeon to command robotics arms to execute micro incision, which is the accuracy beyond the human hand. Similarly, autonomously distribution centers rely on the coordinates robotics fleets to sort and ship packages. Alright, so now let's move on to the next page. Alright, so 5G and next generation connectivity. So it is the fifth generation of wireless technology, faster, denser, and smarter than anything before. Alright, so speed versus 4G Live. So it is a 100 times faster download speed with ultra low latency. Alright, so 5G connectivity, it is commonly see on our phone. Alright, so some of phones there are a 4G only, 4G LTE frameworks, right? So there those smartphones is on depends on how, I mean, it depends on the brands where the company put chipset, which is the 5G, or they put a 4G LTE only. Right, it depends on the company. All right, so when we say 5G, it is good uh, when we browsing internet or we are doing a downloading videos, apps, etc. Yeah. So in this slide is analyze the infrastructural foundation enabling the modern real-time data exchange. So 5G networks. So it emphasizes the leap in cellular performance, which offer ultra low latency or near zero delay. So in bandwidth capacity, it's up to 100 times faster than standard 4G LTE frameworks. Alright, so first is the ultra low latency. So it is enables real-time communication between billions of devices simultaneously. So I have a ultra low latency on my phones. Alright, next is the autonomous vehicles. So it is a real-time V2X communication for safe self-driving navigation. So it is the alright, so it is a device, yes, on we commonly see on the vehicles like car, four wheels, or bus, I think bus, or truck. So you can use communication use on your car, real-time V2X. I don't have, I don't familiarize that because I don't have any cars. So anyways, smart cities. So it is the connected infrastructures for traffic, energy, public safety, and services. So, all right. So next is the telemedicine. So remote surgery, real-time diagnostic, and patient monitoring at scales. Alright, so this hyperspeed data flow is vital for autonomous vehicles. So self-driving cars requires 5G networks. Alright, so when you are driving cars or you have a cars, it is required to have a 5G networks. Alright, it can help with the traffic lights. I can help to communicate when you are in traffic lights, yes, municipal infrastructures, and surrounding vehicles to react to hazard and fractions of seconds. All right. Okay, now let's move on to the next page. All right, so cyber security and the emerging tech era. So it is expanding Expanding attack surfaces demand stronger, smarter build and defenses. So I have a key threats and emerging defenses. All right. So in this slide, it is addressed the defensive realities of an increasingly connected society as the attack surface expand via IoT, cloud, and 5G networks. Security paradigms must be evolved past simple passwords. The material outline advanced modern hazard like driven phishing and automated ransomware, and present defensive measures like AI detection system and zero trust architectures. All right, so okay, first is the K traits ransomware. So it is a encrypt victim data to extort payments. All right, so it is a commonly uh, see on the internet. I think I don't familiar with this ransomware. All right, so phishing it is social engineering via deceptive emails and links, or either calls or text on your phone. Yes, phishing is a scam. Then data breaches. It is unauthorized access to sensitive information, just like link. All right, so when you click that link, your account will go into goodbye. All right. Okay, so now is supply chains attacks. So exploiting third-party vendors and software dependencies. So I don't have any example about the supply chains attack because I don't familiarize I don't familiar with this um, threats. All right, so now we will go into emerging defensives. All right, so in this era, AI driven threat detections. So real time anomaly detection across millions of events. So AI driven threat detection can be used when going to detect something like threat. All right, so it can help to detect anomaly. So it is a globally because it is across millions of events. Yes. Now is the zero trust architectures. So never trust. Always verify. Every access request is authenticated. So zero trust architecture. So it means these are the security on your account. For example, just like what I said earlier, the when you log in your accounts on your Facebooks, it requires authentication code or authentication. I don't know what is that. Just like that. So it can be used to open your accounts. All right. So never trust, always verify. Okay. Next is the quantum resistant encryptions. It is a post quantum algorithm to future proof security protocols. Yes, I don't have any idea about that. Then the security must be built in, not bolted on, and every emerging technology systems. Right. So modern enterprises implement a zero trust approach across the networks. This architecture operates on the principle of the never trust, always verify. Alright, so meaning an employees must be authenticate their identity every single time they try to open new internal files, or eliminating the assumptions that anyone inside the network perimeter is safe. Alright. Now let's move on to the next page. Alright, so last two pages. Okay, so in this slide, it talk about the societal and ethical considerations. Alright, this critical side emphasizes that technology cannot be developed in a vacuum. So alright, it brings attention to unattended negative consequence of the 4IR, or the fourth uh, revolutions, innovation revolutions, detailing the digital divide into social, economic inequality caused by unequal tech access, privacy erosions, the high environmental carbon footprints of a major data, and algorithm bias. Alright, first, the digital divides. So digital divide is an unequal access to emerging technologies depends existing inequalities across religions. Next is the privacy concern. It's a mass surveillance, facial facial recognition, and data harvesting erode personal privacy. And algorithmic bias. It is systems can reflect and amplify human prejudice at unprecedented scales. And lastly is the environmental impacts. So the data centers and crypto mining consume vast amount of energy globally. So the path forward is the governance frameworks, international regulation, and responsible innovation practices must evolve alongside the technology themselves. All right, so um, an AI powered by the recruitment engine trained on historical corporate hiring trends can systematically discard qualified application from the underrepresented demographics because hen- it inherits the unconsciousness of systematic biases present in the human data it was given. All right, now let's move on to the next page. All right, so it is the last page, which is the key takeaways on chapter 1. All right, so first is emerging technologies are reshaping every aspect of human life. Yes, that's true. Then understanding them is essential for students if you are a leaders or a policy makers. And AI, IoT, blockchain, cloud, big data, ER or VR, robotics, and 5G are the core pillars. Alright, so the core pillars are these, the AI, IoT, blockchain. So, right, so that is the core pillars. Then next one is the each technology brings transformative opportunities and ethical challenges. And the goal is to learn to harness these technologies responsibly and effectively. So this concluding note serves as a call to action for students and business leaders reminding them that mastering technical mechanics is only half the battles. So the ultimate goal is the responsible implementation of this innovation within the wider societies. So it is the end of the chapter 1. All right, so I hope you learned something about the introductions to emerging technologies. So some of discussion it is a basic, but uh, yes, it is a basic, but you can learn something new about the technology and the history into the present one. All right, so that's all. Thank you. See you soon. Bye bye.